Lesson 2.5, Evaluating Absolute Value Expressions. Our essential question is how many solutions can an absolute value equation have? So today we're going to be focusing on equations that have absolute value bars in them. Okay, our first equation that I would like you to consider. If f of x, the absolute value, if the absolute value of x equals 5, what could x be equal to? So think about this. If the absolute value of x is equal to the number 5, what could x be? Well, hopefully you remember that the absolute value of 5 is equal to 5, and the absolute value of negative 5 is also equal to 5. So my answer would be x could be 5 or negative 5, and then I'm going to write because the absolute value of 5 equals 5, and the absolute value of negative 5 also equals 5. So that would be my reason. So there are two different numbers that x could be because both of them have the absolute value of 5. Now, making this problem a little bit trickier, I'm wondering how many people can figure this out in their head. What could x be if the absolute value of x plus 1 is equal to 5? So, this absolute value is a little bit trickier. Hopefully most of you can figure out that 4 plus 1 is 5, and that absolute value would equal 5. And then probably some of you can figure out the other one, maybe not everyone. But we know that the absolute value of negative 5 also equals 5. So what value of x could you substitute that would give you negative 5? That would be negative 6. Negative 6 plus 1 is negative 5, which also has an absolute value of 5. So I'm going to say x could be 4 or negative 6 because, and you've got my reason already. If you substitute them where the x is, they both give you the answer 5 for their absolute values. All right, now I don't expect you to be able to solve all of these problems in your head, so I'm going to give you a method here. So basically what we were just doing is we were figuring out what x could be. And remember that this stuff inside the bars, this stuff inside here could be equal to 11 or it could be equal to negative 11 because those are the two things that give you an absolute value of 11. So the stuff that's inside of the bars, could be equal to 11 or negative 11. So maybe if I shift this over, it'll make a little bit more sense. Move my equal sign. There. So what I'm saying is the absolute value of 11 is 11, so is the absolute value of negative 11. So you've got to take the stuff that's inside the bars and set it equal to those two numbers. So case 1, I'm keeping everything positive. So 3x minus 1 equals 11. Case 2, I'm just changing that 3x minus 1 and saying it could be equal to negative 11 because that absolute value would still turn it into a positive 11. So now I have two equations to solve. I can solve them at the same time because they have the same action steps. So if I add 1, 11 plus 1 is 12. Add 1, negative 11 plus 1 is negative 10. And then divide everything by 3. The action steps always stay the same on both problems. So I will get 4, positive 4, and negative 3.3 repeating. Now, part of your assignment today involves graphing. So, on my number line, 0, 1, 2, 3, 4, -1, -2, -3, -4. X equals 4 would be right here, and -3.3 repeating right there. So your solution is x equals 4, or x equals -3.3, and graphing them on a number line just means 2 dots. That's it. Those 2 points are solutions. Next one, same process. So case 1, if I keep it positive, 2x minus 1 could equal the positive 7, or the stuff inside the bars could actually equal -7. Solve them at the same time. Add 1 on both sides of both equations. So 2x equals 8, or 2x equals -6. Divide everything by 2. X equals 4, or x equals -3. Sometimes your answers are both integers. Sometimes they're an integer and a fraction. You never know. Sometimes they're both fractions. So positive 4 is my first dot. -3 is my second one. Those are my 2 solutions. So far, both problems have had 2 solutions. This next one, still 2 solutions. The stuff inside the bars could be equal to 14, or it could be equal to -14. Solve them at the same time. Subtract 2. So -4x equals 12. -4x equals -16. Divide by -4. So x equals -3. X equals +4. You don't have to get a positive number and a negative number. It's pretty common though. So -3, +4. My 2 solutions. Now this last example. This last example is different because after the equal sign, we have a negative number. So I need to make sure that you clearly understand this. Can the absolute value of anything equal -1? Anything at all? Can it have an absolute value of -1? The answer is no. No. Those bars represent the distance away from 0. There is not a number, there's not anything that is a negative distance away from 0. So we do not do case 1 and case 2. This inequality equation has no solution. Has no solution. So, because what they're saying is the answer to the absolute value problem has to equal -1, and that is impossible. That is impossible. So, the absolute value cannot be negative. It's a distance, and distances cannot be negative. When you measure distance, you use a ruler, you use a meter stick, a yardstick, a tape measure. You cannot get a negative number. All right. Now, we've got to click and drag. And you may notice that we've got 2 solutions, 1 solution, and no solution. We've actually got 3 options here. So the negative numbers after the equal sign, that's what gives us no solution. So we just talked about that. Those are no solution. Make my circle a little bit bigger. Okay. We know that when it equals a positive number, that there are 2 solutions because that x plus 7 could equal 5 or -5. So these 3 have 2 solutions. So I want you to look at the last 2 that are left and think about it for a minute. Why would the ones that have a 0 after the equal sign, why would those only have 1 solution? Well, that would be because 0 doesn't have an opposite. Like the 5, the 3, the 14, where you could set it equal to 5 and then equal to -5, or 3 and then -3. Well, if it's equal to 0, there is no -0. There's no -0. So there wouldn't be 2 equations to solve. There would only be 1. There would only be 1. All right, you should be able to write your summary now. Make sure that you use complete sentences and restate your essential question.